Alright guys, so we will be talking about polynomials, which basically means the word poly is many. Um, it's basically something with a lot of parts. So there's three ones that I will talk about right now. And we have them right here. If you notice, this has 1, 2, 3 terms. I shouldn't say parts, the correct terminology is terms. So it has 3 terms. This is called a trinomial. The prefix tri is 3. Triangle, 3 angles. This one has 2 terms, so we call it a binomial. Binomial. Bi prefix means 2. This is 1 term, and you guessed it, it's called a monomial. Okay? I think I spelled that wrong. Monomial. Forget about that. So, it's a monomial since it has 1 part. Okay? That's the easy part. Actually, all this is easy. But that is a trinomial, binomial, monomial. Anything more than 3 parts, whether it has 4, 5, 6, 7, 3 trillion, we just call it a polynomial. There's no more fancy names. There's no quadnomial. Just a polynomial. The next thing we need to know about is what is not a polynomial. Well, if you look here, we have x squared plus the square root of x. If you ever see a square root of x in your terms, not a polynomial. The square root throws a lot of things off, so it's not a polynomial. Should be a space there. Also, the other big dead giveaway is if you have x to the third plus x to the negative second. Okay. If you remember the rules of exponents, this is really x to the third plus 1 over x to the second. Since there is a variable in the denominator, that's not a polynomial. Okay. Just some hints on what is and what is not a polynomial. So make sure all of your exponents are positive on the numerator, and you don't see any square roots, cube roots, any of that fancy stuff. Okay. So, sorry I'm going fast. It's just, you can pause me if you need. We're going to say, let's have x to the third minus 4x to the fourth plus 3x minus 2. Okay. One of the biggest, most important things when you deal with polynomials is when you're done simplifying them, or before you factor them, which you'll do in the next chapter, in chapter 9, is you need to put them in descending order. Okay? So, descending order. Now, the word descending, if you've ever been on, I don't know, a roller coaster, snowboarding, skiing, tubing, what have you not, descending, or an airplane even, descending is when you're going down, okay? You're going from a high location, and you're going down. So this is our little slider, descending down the mountain, okay? So it's going from a high point to a low point. But what that means in polynomials is you want to look at the exponents. So if you look here, we have a x to the third, x to the fourth, x to the first. There's really an x to the 0. But x to the 0 is just 1, so we don't write it. So this is not in descending order because we need to go from high exponents to low. So we take the negative 4x to the fourth, put it out front, and then x to the third plus 3x minus 2. Now this is in descending order, and we're looking good. Okay? Another example of that would be negative x plus 4x squared minus, let's say, plus x to the fourth plus 2x to the third. Not in descending order. Descending order would be x to the fourth plus 2x to the third plus 4x squared minus x. Okay, so when we talk about polynomials, after we put them in descending order, we want to look for the leading coefficient. Now, if you remember from the beginning of the year, which you should know this all the time, a coefficient is a number that is attached to a variable. So the coefficient here is 1, 2, 4, and negative 1. The leading coefficient here is the coefficient that leads the train, or that's attached to the highest exponent. So our leading coefficient here is 1. The next thing you want to look at is the degree, which again is the highest exponent in your polynomial. So we have x to the fourth leading the caboose. I think that's the front of the train. So our degree is 4. Those are two things that don't mean much now, but when you get to higher level maths like algebra 2, pre-calc, maybe geometry, you'll need to understand them and know them, and it'll help you out. So if you go back to this one, actually, our leading coefficient is -4, since it leads the train, and our degree is the highest exponent, which coincidentally is 4 again. Okay, and that is how you put polynomials in descending order. Look at the exponents to go from high to low. But on this one, if you notice, we're missing x to the second, but that's okay because it still goes 4, 3, 1, and x to the 0, which we don't write x to the 0. All right, so on the next problem, we will take a group of polynomials and let's add them. So we have 3x squared plus 2x plus 4x plus 7. Okay, so if you notice, we have a quantity here and we're adding it to this quantity here. Now if you notice, mathematically, the first thing we should do is distribute, since we have a positive one here and a positive one here. It's going to seem trivial for this example, but it makes sense in my next one, that you would distribute a positive one, but of course we all know when you multiply by a positive one, nothing happens. So you're left with 3x squared plus 2x. Distribute this positive one. We're left with 4x plus 7. Nothing happens. So now we're left at this step. And this is a step where a lot of my kids kind of messed up or forgot, but it's a common mistake among algebra 1ers. So if you look, we need to combine like terms. Since we're dealing with bases of x that have different exponents, you can only combine things that have the same exponents. So if you look here, we only have 3x to the second. Nothing else has an x to the second. So this guy is alone, doesn't get to blend with anybody. Now if you look here, we have x to the first and another x to the first. So 2 plus 4 is 6x. The big thing you don't want to do, a lot of my kids, since this is an exponent of 1, they added those and would write 6x squared. But if you remember from your rules of exponents, we only add exponents when we multiply your bases. Since we're adding these, nothing happens to the exponent. And we're left with a plus 7. And that's your final answer. Okay? Next example, let's take a 4x to the third minus 2x plus 5 minus the quantity, I don't know, negative 2x to the third plus 2x squared minus 4x plus 5. Okay, now this is where the idea of there being a 1 out here and distributing it is going to change some things. The first quantity, distributing a positive 1, nothing's it'll change there. Okay, so it's still 4x to the third minus 2x plus 5. But this bad guy right here, this negative 1, is going to change something. So we all know that when you multiply by a negative 1, the value or the number is not going to change, but your sign will. So a negative 2x to the third becomes a plus 2x to the third. A positive 2x squared becomes, just kidding, it becomes a negative 2x squared. A negative 4x becomes a positive 4x. And a positive 5 becomes a negative 5. So we basically got rid of our parentheses. It's the first thing is simplifying or evaluating an expression. Now we must simplify our combined like terms. Again, look, since we have x to the third, everything else with an x to the third. Boom, got one. And that's it. So we're going to have a 4x to the third plus a 2x to the third gives us 6x to the third. Let's move on to this guy. This is an x to the first. Here's another x to the first. Negative 2x plus a 4x is a positive 2x. You can put in your calculator, negative 2 plus 4 will give you a positive 2. Put the x in the end, whatever you want. Then here we just have a constant, okay, and a constant. Positive 5 minus negative 5 is, well, good for us, it's 0, so I'm not going to write it. And here's our bad guy. He's all left alone. X to the second minus 2x squared. Okay. And a lot of you guys would finish here, but like I said a couple slides ago, you need to put this in descending order. So in descending order, we have 6x to the third minus 2x squared plus 2x with a leading coefficient of 6 and a degree of 3. Okay? That sums it up for adding and subtracting. What I will do in the next video is multiply polynomials.